And with that introduction, I'd like to introduce our panelists. And first coming up would be Isaac Bennett. He's the Global IT Innovation Manager for Maxi on Wheels. Then we also have Sankaran, I'm sorry, I can't pronounce it, Supermarian, from John Deere, who's a senior staff engineer. Paul Redwood from Church and Dwight. He's the chief product officer and head of, oh, I'm sorry.
Thanks for the promotion.
I'm sorry, yeah. I'm sorry, R&D manager from and also representing OMAC and OPC. And then we also have Kevin McDonough. He's the chief product officer and head of strategy for UI Labs. This is where you get promotions, Paul.
Yeah.
So what I'd like to have each speaker do is introduce themselves and really tell me something about your company and about some high-level perspective, what the scope of your operations and the products you produce are. So what is a typical customer purchase from your company, and what is the relationship over the product lifetime? So why don't we start with, we'll go left to right here first, if that's okay. Paul?
Yes, sure.
You need a microphone, if the handheld is right there.
Slide.
Oh, yes, thank you. All right.
Good afternoon. How's the energy level? All right, we're going to try to keep it going here, guys. First of all, I'd like to just talk about Church and Dwight. This is a 170-year-old company that competes in a land of giants. We have 11 power brands, which comprise about 80% of our sales. The organization size is about 4,000 people, and we're about $4 billion. We operate in a complex landscape. As you see, we grow by acquisition. In fact, we've just about tripled the business in a period of about 13, 14 years. So Wall Street thinks we do a good job of integrating these businesses, but we have lots of room for improvement from a machine level, a line level, a plant level, and even an enterprise level. It's in also, you see our logo, that well-respected logo for the Arm & Hammer, showing the Roman god of Vulcan with his anvil. So I just want to warn my associates here in the panel that those at Church and Dwight, we get accustomed to thinking a hammer is our best tool. Therefore, you guys are now nails, okay, for the rest of this session. I want to introduce myself real quick in terms of the next slide real quick. This is OMAC. I'm the chair the last 18 months for PAC-ML, Packaging Machine Language. It's an open standard for interface of different machine control platforms. We have over 70 member companies as well as partners. And one more slide. I've got to introduce myself 3 times, guys. Okay, let's just skip that one. We're celebrating our 25th year with the PAC-ML standard. That's what that slide is all about. This one is about OPC. I'm in the seat today because OPC gave me an opportunity to be their evangelist, their mouthpiece. So I want to thank them, and I want to point out, of course, that this is the ecosystem going forward. Great growth, amazing stuff. Let's move on. Let's move on, Sal. But I want to remind you this was before, okay? You guys have experienced this. So did we at Church and Dwight. Single vendor solutions, data that we had to go chase down, and we found out we had to pay extra for it. Systems we brought in for computer maintenance management that we couldn't talk. Everything was locked, bottled up. So once again, the real estate adage applies here. It's all about location, location, location. And OPC has found a sweet spot in terms of location in this technological landscape that they are the growth engine here going forward. This is scalable, this is reliable, relatable, securable, and formidable, the position that they're in right now. And I just want to thank them for giving me the opportunity to speak.
Okay. Thank you, Paul. Okay. Why don't you go ahead, Kevin, please? And then
Sure.
I'll queue up.
So again, I'm Kevin McDonough, and I represent UI Labs, which I don't think we have a slide.
We do not.
Yeah.
I'm sorry.
Which houses the nation's Digital Manufacturing Institute. So it's known as DMDII, Digital Manufacturing and Design Innovation Institute. It's based in Chicago. We're about 5 years old, and we're one of 14 Manufacturing USA institutes in the country, one of the earlier ones of the 14. And we're funded by the Department of Defense, but we exist in order to transform U.S. manufacturing across all industries, the entire industrial base. A lot of our members are participating in this conference. Companies like Dow, Lockheed Martin, Rolls-Royce, Duracell, Coca-Cola, John Deere, Caterpillar are just some examples. We've launched 63 R&D projects that focus on problems that are too big for any one company to efficiently address on their own. So we bring together companies like this along with about 49 academic institutions, along with startups and solution providers to address problems across digital manufacturing and supply networks. We have a lot of artificial intelligence and IoT related projects. I imagine I'll share some of those along with the questions throughout our time together.
Thank you very much. Now, Sankaran, please. Is it on?
Can you hear me? Yeah. Okay. So my name is Sankaran Subramaniam. I'm from John Deere, so I'm sure everybody's familiar with John Deere, but I'll just kind of bring the next slide. This is not a marketing slide by any means to show what we're doing, but some of the questions I will answer later on will reflect on the challenges we see. So many of you know John Deere as a tractor company, but this is a very small fraction of the products we make. So we are really broken down into agriculture, lawn and garden, landscape grounds, golf and turf, and then we have our construction and forestry business. So within each one of these, there's quite a few range of products. So we make stuff that's sold in Lowe's and Home Depot all the way up to a cotton picker, which can cost $1 million. So there's a huge spectrum of products we make, and then a lot of things that go into the business. So one thing that's not shown here is a little over a year ago, we acquired a company called WorkGun. So we are also in the road construction business. So WorkGun is a German company, which is the second largest road construction equipment manufacturer. So next time you see road construction, see if you can find a WorkGun. So that's a John Deere company. So you won't see John Deere there, but you'll see a WorkGun. So the reason I'm trying to show this is the complexity of the products we make, all of these systems, and then we'll talk more where some of the things we're talking about in this forum are very relevant on things we're trying to do as a company to service our customers and also provide the needs to the market as well as our stakeholders. Thank you.
Thank you very much. So, Isaac, please.
Yeah, my name is Isaac Bennett. I come from a company called Maxion Wheels, and actually Maxion Wheels is the biggest wheel manufacturer in the world, not to be confused with tires. So we make steel wheels, we make aluminum wheels, and we only sell to OEM. So that's why you probably never heard of us. And previously our company name was Hayes Lemmertz, and Kelsey Hayes actually put the wheel on the Model T. So our company is very old. We've been around for a long time, and we make a lot of wheels. And one out of every 8 wheels is one of our wheels. So we're a global company, 26 plants all over the world, and I'm happy to be here. And I have to say, if you have a chance to go down to DMDII, please do. It's a great experience to go down there too.
Perfect. Thank you very much. Okay. So with that, I'd like to really ask the next question, which is, get it on the screen here. Well, each of these companies has challenges. And so what I want to do is actually, if we could give a short summary of some of the challenges that you're confronting in your manufacturing operations. And Kevin, in your case, you may reflect on some of your member companies and what challenges they have. But maybe we'll just go back to Paul, if you could. Just give us a short discussion on that, please.
Yeah, we're facing a myriad of challenges, from the demands to get our product out, get our lines ready to change them over to meet the needs out there. That's pretty much to make sure we don't cut orders, get inventory levels right, and to really move the business in terms of growth. So we're not facing anything unique. Everyone is facing similar stuff.
So I have the opportunity to see a lot of manufacturers' environments as we, are invited to tour their operations and to also be the receiver of a lot of their problems that they wish to solve together. And a lot of them revolve around access to data, which of course is a prerequisite for applying artificial intelligence or machine learning. It also, cybersecurity is a key concern where IT departments are skeptical of new technologies that might expose information in their machines or make them subject to attacks. Another one is the fragmentation in the supply chain. There are many cases where it's desirable to collect data from suppliers who are much smaller operations, less sophisticated, less resources available, both labor and capital investment, in order to access data in those machines and securely transfer it to, the prime customer, if you will. So these are pretty common issues. I think the other one that could be lost in the technology noise is just identifying high-value use cases. Where do you start? A lot of companies are overwhelmed by all of the options and choices and seem to be struggling. We find that the forum that a nonprofit pre-competitive institute can provide helps these companies kind of sort that out with peers, sometimes from entirely different industries, and forge a strategy that makes sense for themselves.
Okay.
Okay, from Johnny's perspective, I'll focus a little bit on the manufacturing or operations side of it. So every business unit, all the different products you saw, they're made globally. Every factory run as a business unit, and 4 key metrics that every factory has to meet is therefore really safety, quality, delivery, and cost. Safety is top priority. We pride ourselves in millions of hours without lost time injury. So that's always, it's a given. We don't make any compromises on safety. Quality is our brand reputation in the market in terms of what we deliver to the customer, in terms of fails per machine and the warranty costs or the quality of the product we deliver. The last 2 are the ones, delivery is the one that's always a challenge because you have variation in demand. I'll talk about an example later on where machine learning is a possible application we're looking at. Delivery is always a challenge in terms of variability in demand, variability in supply, how things come through the factory. So delivery is always a challenge. We have found ways to manage it. We are a process-oriented company. So then cost is always critical. How can we deliver what the customer wants at the lowest possible cost? So one thing always we make fun of internally is, I came from automotive, so I know how cost pressures are in automotive. I have a different perspective at Deere, so we always say, Deere, we want aerospace quality at automotive cost. So it's really hard one to find. So anytime you justify a new technology or new way to do things, it's always, cost is always the driver. So not only to deliver profits, but also in terms of what we can deliver to the customer. So those are key things in terms of what are the operational challenges. And one example I can give is if you look at a combine, which harvests corn or grain or rice, or if it's harvesting corn, soy, sugarcane, or cotton. So a combine has 18,000 parts in it, and quite a few of them come from suppliers. And then having the parts come in time and deliver and not have a line down at the same time, you don't want to use a whole lot of inventory either. So those are challenges in our industry that we are constantly faced with, and we have processes that have been developed over the years. By the way, we started 1837, so we've been around for a while, and hopefully we'll stay around for another 100 years. There's no guarantee, but we hope so. That's what we are the journey for with this whole digital transformation, how that's going to be impacting our industry also in a big way.
Perfect. Okay, thank you very much. So Isaac, could you give a perspective of your challenges?
Yeah, I think in general, the world is a much more agile place than it used to be. I mean, things change much quicker than they used to, all the way from political landscapes to markets. And I think that reflects from a manufacturing perspective, in our perspective, we have a lot more part numbers than we used to run. people are expecting customizations, and for us to keep costs down and still deliver what's expected in the world where people are expecting to have, different colored wheels, different style wheels. In the old days, it was just the same style wheel we ran it for a year, the same part number. So that's changed quite a deal, and I think that's one of the biggest challenges we're facing. And then from the perspective of digital transformation, and it was mentioned, the data. Now, what data do we collect? How do we collect it? And what do we do with the data? Because we don't want to collect data just to collect data. So we need to have a business case behind that. So there's a big discussion about what data to collect, what data is important, and how do we collect the data. So.
Thank you very much. So now I think we'll dig a little bit into really the topic of this session, and that's machine. I'm sorry, how did I?
Yeah.
Okay, can I?
Yeah. You can go.
Okay, sorry. Excuse me. So what I'd like to each of the speakers really talk about is what we're here for today, talk about machine learning and what machine learning initiatives in your organizations are you undertaking to mitigate the variability in operational metrics and improve production quality. So I'm looking for here really some real application of machine learning, not visionary or out in the future types of learning applications. So I think I'd like to hear a little bit from each of you on this. And actually, would you mind going to Sankaran first?
Sure, I can do that.
I think that would be great.
Yep.
Did you have a slide with this? Right?
Yeah, so I'll spend some time on the manufacturing side, but I want to show a small video here, which is a product related, which might be very interesting for everyone to see, just to show that John Deere is investing pretty heavily in this space, to show what we are trying to do from the product side. Okay. So I don't know anybody heard about Blue River Technologies. So we acquired them a little over a year ago. I'll play a short video. It'll give you really true power of what AI can do and what it can be useful for. And I'll talk a little bit more about the rationale of why this is important, not just for John Deere, but also to the farming community as well as the rest of the world. So if you want to play that.
Go?
Yeah. Oh, there should be a video. If you click on that link.
Oh, could you click on the link, please, sir?
Start showing. It goes to a YouTube video.
Is it?
Yeah.
Okay, sorry.
No problem. It's only about 2-minute video, but it's pretty fascinating what this does.
Network here isn't so good.
Huh?
I'm sorry?
There you go.
Oh, okay. Well, while we're waiting for this to set up,
So while we do that, I can give the other things I want to talk about what John Deere is doing in terms of using machine learning. By no means, somebody had a great message in the early keynote speak that not everybody is at a end, so everybody's in that journey in terms of these technology. So there's a few things that we are trying out to see. I'll share some examples. One of the areas we actually have a pilot deployed, and we are trying to actually, that's actually in the system that's being used today, that I deployed a few months ago, is in inventory optimization. So the reason is we all want enough. So when you talk about inventory at John Deere, we are a big company. Inventory not just goes into millions, but hundreds of millions or even billions of dollars worth of inventory in our factories. So we are trying this out at one factory, which is basically a safety stock optimization for our MRP system. So there's a lot of time series data in terms of safety stock, demand variability, safety buffer, how much buffer we need to have at the factory for production. There's material movement inside the factory. and their supply performance, and several other metrics that impact how much safety stock we have. So what we have is, we are a big SAP house, so SAP is our big database, but not all our data is in one place. So what the system does is it takes the data from the SAP into this machine learning platform, and using all these about 10 to 15 different measures, it predicts. We trained the data with about 2 years of data, historical data, and started training it, and now the system is giving recommendations. By no means it's completely automated, but it's giving recommendations to the buyer. In that factory, we have about 14 buyers. Those 14 buyers, at that point, the system comes and tells us, this is the time for you to order. If you don't, right now, based on what the system knows, okay.
You want to finish?
We're seeing lots of
Let's do that
resistance
first.
to Roundup. We're looking for other ways to combat the weeds and still have cost savings on top of everything.
We saw an opportunity to take cameras, computers, and artificial intelligence to allow ag machines to see every plant in a field. We thought that we could give farmers the ultimate flexible tool to treat their field and manage their field in whatever way they wanted by having the knowledge of every plant and its situation and an ability to spray very precisely, whether it be herbicide only to the weeds or fertilizer or fungicide directly on each plant that needed it.
Each field they go to has a different set of conditions, and they need to be able to adjust and correctly set that machine's performance for the field. One knob could be the protection of the cotton plant and how big of a buffer, a safe zone that we provide the plant so that when we apply selective materials or non-selective materials that we have the appropriate buffer. Another dial is how aggressive do you want to be at going after anything that looks like a weed. There's also some opportunities to inform the grower of how many weeds the system's seeing, even what kinds of weeds exist in the field, that they can start to tailor their herbicide programs towards those weeds.
The cameras and computers on the See and Spray machine are using deep learning algorithms that are similar to what's used in facial recognition. The first time we saw a pigweed, the machine didn't know what kind of plant it was, but we taught it by giving it tens of thousands of examples of that pigweed, and now it's an expert in pigweed. We save up to 90% of the amount of herbicide that you would spray if you were spraying the entire field.
The weeds have become a little bit more of a pest than what they were originally. They've become resistant to a lot of the herbicide that we've been using on them.
With the rig, we have other options open to us. We can spray different chemicals that we're not able to spray before. We can take one man and put him on a tractor, and we can do the work of 8 to 10 people.
We're seeing no end to the use of this technology. Essentially, anything that may be cost prohibitive or more difficult to do when you're spraying on a broadcast basis, but much more grower beneficial if we're spraying on a very precise basis.
So the farm is just another production operation.
So I want to briefly reflect on that one. So this is a pretty neat, we are really into a lot of precision agriculture. So this is part of our precision ag business on what we are trying to do. So give an example why this is very important. So they say they use about $25 billion worth of herbicides globally to treat weeds. And as you probably know what we do at home too, we put this Roundup on weeds in our lawns. They say over 200 species of these weeds are no longer effective to these herbicides. So it's a pretty important long-term play globally for mankind in terms of what this can potentially do. So this is definitely a big area for us that we really recently got into and acquired this company with the potential of what it can provide. So I want to share that. So I'll go back to the example I was talking about with the inventory optimization. So like I said, so we're using this thing for the inventory optimization project. So the system is online for last few months. So I don't have any information on the savings yet. It's too early to say. We'll talk more about why it's important to do the investment. It's not always, the ROI is not always there right away, but we have a system in place, and then the buyers are actually seeing the output of the algorithm, and it's learning regularly as data is getting better. It takes time, as you know, with machine learning, it needs to learn and gets better with time. And the biggest thing is the buyer needs to trust the system is predicting correctly. So some early indicators is that once the recommendation is made, about 70 to 80% of the cases, the buyer has actually made decisions either to stick with what was recommended from the system, or he made some adjustments. He didn't completely blow out the prediction, but we are in the process of making those adjustments, and then the people who are actually doing it, though it's not fully automated, but actually there's a human element making decisions based on the output predictions of the machine learning model. So that's one area that I can give example of we are in the process of using machine learning for in terms of inventory optimization. A couple of other areas I want to highlight is I do a lot of work in process development. So I was a Six Sigma guy for years, taught Six Sigma, and got quite a bit of knowledge with statistical methods and statistical principles. And we have always used design of experiments to create our data stream, to create our optimal experimental design so that I can create models for processes. So there are some big benefits of doing that approach that you want to make sure. One thing to always remember is you just don't throw lots of data just for the sake of data. You want the right amount of data. Always remember, garbage in, garbage out. So the machine learning model has to have the right data. So you want to have data that is representative of what the process is. So in that space, we do use a lot of things at the early technology development phase to develop processes and optimize processes. So build neural network models to do process optimization, whether it's a welding process or it's an additive process. We use some of those techniques at a smaller scale. But a bigger bang for the buck is stuff like optimization from the business side when you talk about millions of dollars. The other one is, I would call is in the process control. That's one of the DMDI projects that we have been associated with, is to understand weld quality. So when you do a weld, so we are a big we do a lot of fabrication in our factories for all the product lines. So you have weld quality data, whether you have porosity, you have penetration, you have different characteristics of the weld that you want to make sure the weld quality is good, because these are structural applications that are load bearing. They carry load on the field, whether it's a farm or a construction site. So you want to be able to tell when we made a structure, it's coming out of the line, the quality of the weld is good. So we are not there in production yet, but we are doing that some at the lab level to test out some concepts with these algorithms and classification methods to see if the system really works. So that's another space that we are working on. So these are a few areas I can highlight in terms of what Deere is trying to do with machine learning. Somebody had a question.
Yeah, well, let me let Isaac speak, and then we can jump in.
Yeah, one last comment. By no means we are an AI company completely, but it's still new to us. We are in the process of learning and finding the benefits of these technologies where it makes sense. One thing to always remember, if you have a hammer, everything looks like a nail. So be careful. So you don't need machine learning and AI for everything. Use common sense too. So don't get blinded by these things, but at the same time, be smart about it, making best use of where it's needed. Okay?
Go to Isaac, and you can talk about your casting operations.
Yeah, we started looking at the data coming off casting machines. There is over 300 parameters coming off aluminum low pressure casting when you cast a wheel. And you can imagine 300 parameters, even if the guy has been with the business for 30 years and he's been looking at that casting machine, he doesn't know exactly why a wheel is scrap or why it is or isn't scrap. So traditionally in the business, the high rate of scrap happens in the aluminum side of the business. So we've pulled data off those casting machines, and we've used data scientists and started analyzing that data, trying to find the parameters that were the most important parameters that would contribute, the most likely parameters to contribute to a bad wheel. And we've had some good success so far with our pilot projects, and unfortunately we're looking at we haven't in the past marked those wheels through the entire manufacturing process. So that's the next step where we're at. We've kind of proved that yes, there's a good value in this, and if we can stop that wheel before it goes through the rest of the processes, and we know that wheel is going to be scrap, that will be a big benefit to our company. Yeah.
All right, thank you. Isn't there a song called "Stop That Wheels"?
Yeah.
Okay, then, Paul, please, I'm going to flip to your slide where you have obviously implemented some machine learning.
Yeah, I'm going to talk about our application for Vitafusion Little Critter gummy bears. First of all, what you're seeing there is before that manual operation. Go ahead, click, and let's look at that's the Tomra Best vision system, which it's pretty much just configured with lasers and CCD cameras. And that's just showing you a close-up view of the inspection tunnel as the product goes through. And that last session, let's click on, that's a video integrated. Just click on that, let's run that. It's only about 25 seconds or so, just to give you a sense of the technology that's in play.
So, excuse me, just for
Yes.
clarification, the top part is the older system and the bottom is the,
The upper left is the old, upper right is the new.
okay. And that includes the
Yeah, that
the vision
includes,
tunnel?
yeah, the tunnel, which is a part of that system. Okay?
Perfect.
Now, just imagine, those gummies are coming at about 30,000 a minute, okay? So very difficult, very demanding job in terms of trying to inspect in quality.
So just out of curiosity,
Yeah.
how many parameters are, like, we're talking about casting, you said there were, how many parameters?
Over 300 parameters.
Over 300, how many parameters are you control for a gummy bear?
Oh, well, let's put it this way. I won't be able to answer in terms of number of parameters, but we acquire a lot of companies over the years, you saw, and we try to make them asset light. This was asset intensive. In fact, we thought how difficult it would be to make a gummy bear. Guess what? This is one of our most difficult products to do. Very, very difficult. The whole process all the way through packaging. What, as he's trying to cue up that video here, just the lower right photo, you see the belt sorting principle? Just tap on that and the video will pop up. Down towards the bottom, then you'll see a play button that will pop up. Bottom half. While he's doing that, I'll just talk through it. So what you're going to see, basically, that belt is going to run. You'll see, good product, green, bad product, red. It'll come, there we go. So looking down, we have a bunch of CCD cameras as well that inspect the product on the belt. And then when it leaves the belt, lasers are doing inspection as well. Good product, continue on the path. Bad products are ejected down. So that's in a nutshell. However, that's done by teaching it and training it, putting product on the belt on the in-feed to set up the initial recipes. Then you could get anything that you have not taught it, put it on that belt, and it's going to know and learn and pick up and identify that. It's pretty neat stuff. The machine's actually called a genius. However, there are jobs that even this genius has difficulty with, and that is simple stuff like if a gummy bear is missing its nose, it cannot detect that. So please don't call our consumer complaint line and complain about your gummies missing the nose. We'd have to start a whole new project to deal with that. All right. No, that's fine. Now, this technology comes from the fruit and vegetable environment, where the John Deere equipment is out, and they developed that with the whole idea, and they don't worry about false positives, meaning good product that you reject. That's why they said this became their #1 application. If they have a mice mixing with fruit or vegetable, or a dead bird, they will, any means necessary, identify and kick it out. They don't care how much good product goes with it. Whereas we are concerned about that, all right? Because our bad product is not a rodent, it's not a dead bird. So we challenge them with some new metrics. All right.
Okay, well, great. Thank you, Paul, for that. Okay, did you have anything to add, Kevin?
Yeah, so at the Institute, the Digital Manufacturing Institute, we're more on the front end of, leading edge, if you will, of applications. So there's a few that are pretty interesting. We're working with one CPG manufacturer to itemize every single item they produce with a unique serial number, which will allow the intersection of a lot of other data, including, for instance, the maintenance history of a particular tool that operated on a particular item that's running at, tens of units per second. And of course, the temperature and the vibration and the amount of material going in each item, so that we can correlate across all these variables, performance, failure rates, predictive maintenance on the equipment that's operating on it. And so one of the key enablers there is to be able to cost effectively serialize every item at the rate of production without slowing things down. so that you can put this information in a data lake and identify these patterns. So this is a new project that we're launching. Sankaran had mentioned that with Deere, we're working on a welding project. What's important about this is, like many of our projects, we have a manufacturer like Deere involved. We also have an equipment supplier, in this case ITW Miller, one of the largest welding equipment providers, so that they can commercialize the technology. And we have a university, University of Illinois at Chicago, who's doing the artificial intelligence work. And in this particular case, the intent is to ultimately collect data about the quality of the weld and signals such as acoustic signals coming off the weld as it's happening, so that we can correlate that with a good weld, a bad weld, and adjust in real time the current, the voltage input, the feed rate, in order to assure that the weld is good. So this is going beyond, automatic inspection and kicking out bad welds, but rather while it's producing the part, using artificial intelligence to keep it in control, well in control, and assure a good weld. This is getting closer to the ultimate vision that we have, which is every part better than the last. This is what the fourth industrial revolution could realize for manufacturers when you create learning systems that are augmented by, computer intelligence, IoT, and these other things. And that's what we're encouraging our members, the way we encourage our members to think about this space is not as a bunch of disparate technologies that can drive small incremental improvements, but rather an opportunity to synthesize them, to integrate them in a system that is really all about continuous improvement, but on steroids, reducing that learning cycle to a matter of fractions of a second as opposed to days, weeks, years, whatever.
Thank you. Now, I'd like to take a pause for a minute because I believe we had a question. Mike, is that correct? Yeah, it's great. Wait for the mic over so they can pick you up on the audio system. Thank you. So introduce yourself, please.
Check. All right. Hi, I'm Mike Chen from Omron, Director of Corporate Engineering. So my question was for representative from John Deere. So we are also in AI technologies when it comes to creating models for customers. And I'm really interested about the use case where you said that some of your customers, the learning algorithm learned what type of weeds over time. Right? Mm-hmm. So then in that, and then you also said that your customers are typically taking your suggestions 80% of...
That was a different example.
Okay.
Not for this one. The one 80% I sold was the internal inventory optimization. The customer in this case is the buyer.
Oh, I'm sorry. Okay.
Yeah, so it's
still related question though, is that when customers, when users of AI, when they use a model created by the vendor, just kind of opinions from the panel as to if the model produces a result that they don't like, right? But they have, by social psychologists, kind of taken the recommendation of the AI. Mm-hmm. Is there, do you guys foresee some kind of responsibility type of shifting from the end user to the manufacturer on what happens due to the AI? Because we're in that same type of challenge where customers ask us, okay, if I use your AI, what happens when the decision is made by the algorithm and I eventually don't like it?
At least, maybe let me answer this two ways. If I may not have all the answers you exactly asked for from the customer side, but on the internal side, the inventory system I talked about, that's a purely internal thing right now, which is, internal operational thing. So in this case, the outcome is, if it doesn't, right now, like I said, it's not a fully automated thing. The vendor, or in this case, the buyer, makes a decision still. It's a human element to make a decision whether to take it or not. The thing is, we just don't leave it like that. So if the buyer says, no, I don't like it because of some reasons from experience, what he's seen, so that input so there is a feature within the system that we give a feedback into the system so that it trains to that one for the next time around. So that is not an open-ended system. The way this is designed is to keep that feedback loop if the buyer did not like it. That's on the internal operational side, so that's purely internal. On the customer side, I may not have all the answers to that one because I'm not so close to that business. I want to show that as an example. But of course, with like any AI tool or implementation, It's a matter of trust over time that it starts to predict, and then that's where the challenges will be to deploy if it's going to the customer. So at least from what I know about John Deere, we won't get something into the system, into the hands of the customer unless we are 100% sure. So that's something, a lot of internal work we have to do. And we do a lot of work with on a pilot basis with customers. So we have a lot of farmers who will work early on to try things out before we send it mass to everybody. So we do a lot of that work as part of the development process to make sure those things are ironed out before we release it completely. I don't know if that answers your question.
Okay, thank you.
I'd like to give you a perspective from like a client perspective, because I've been in this position for about 3 years, and I've looked at hundreds of vendors who say they can do machine learning and artificial intelligence. In manufacturing, it's not so easy, and what you alluded to is exactly why. I mean, of course, one of our problems is an aging workforce, and those guys on the plant floor can walk by a machine and hear it or touch it, and they know that there's a problem. So I think, in my perspective, it was really, really important to find a vendor who understood that in the manufacturing environment, but not only understood that, but was flexible enough to come in and work with us, because you can give me a template, but if we don't understand the template, we don't understand the algorithm, and we don't understand how to adjust it, it's not going to work. All machines are different. Every manufacturing company has different machines, and they have different machines in different factories and varying types. And it was really important for me to have a company that had kind of a template-based solution, but then also they would walk into the room with the production guys that have been there for 30 years. And the conversations between the data scientists and the production guys is very fascinating, but definitely it has to happen in order for the system to work. So, yeah.
I'd just like to quickly comment that in that case, Chen, you are still exposed because you're joint and severally liable still. So you're ultimately the user of the product, and you're not transferring that just because you're using theirs.
Okay, well, thank you very much. I'd like to jump into the next question we have in this series, and that's, we'll talk about some of the metrics that were employed here to quantify the operational improvements. You know, whether they use return on investments in these initiatives or some other metrics. Can we speak to that? Paul, you want to jump into that, please?
Yeah, I'll speak to that quickly. For us, our metric, of course, was sorting efficiency that we're looking for, that this machine should remove defects. But more important, we looked at what we call a good to bad ratio. So for every one bad product that was rejected, we only want as to cost us one good product, meaning we'll accept a false positive. That was our criteria, which is unlike anything they'd ever seen before. However, they stepped up and we met that. So that was a key deliverable. We met all the other corporate metrics for this project. In fact, we overcome quite a few challenges. We've never done this before, and the project actually won the Chairman's Award for Church and Dwight.
Excellent, thank you.
Yeah, I'd just add another example of a project leveraging AI actually is led by ForCam. I think Franz Gruber may be in the room, CEO of ForCam. He's one of our members, and his company's leading a project along with Predictronics that combines the solution that ForCam has, monitoring the activity on the factory floor through interfaces. They just formalized an interface with Haas, which helps to bring that brand of CNC equipment, which has a proprietary interface, into a universal dashboard. Then Predictronics is developing artificial intelligence algorithms that allows for predictive maintenance by leveraging some of that same information and then recommending proactive maintenance of the machines to maximize OEE, overall equipment effectiveness. So that's the key metric. Yeah.
That we're talking about.
Yeah.
Perfect. And Sankar, any?
Yeah. In this case, the metric for us, the inventory example is really comes down to the 4 metrics we talked about is around delivery and cost. So if we don't have numbers yet, this is fairly new, so I don't have numbers, but we hope that it'll be at least 5 to 10% improvement in inventory. But as I say, I don't have the facts yet, but again, that data, time will tell what that is. The other thing is, one of the things that I'm learning is we have a lot of customer metrics in terms of quality, performance, so we hope those will improve. But again, that's not only one lever. There's so many levers that impact quality. So I don't want to claim that this particular machine learning project on this one impacted everything. So there is some level of granularity that we need to do. So the other thing is in terms of return of investment. Again, some of these technologies, we are like I mentioned before, we are a process-driven company. We have learned a lot of things over time to improve those processes and be really good at it. Just to say machine learning made a difference, so that is something, but it's an investment we are trying to make as an opportunity. So this time, sometimes when you look at a project and say, I want return on investment on this one, it may not be there. I was in a meeting last week and say, yeah, we have to spend $500,000 to make $1 million saving. So in that case, our $1 million investment to save $500,000. So that level of quantitative return of investment, we are not there yet, to be honest. So that is something we are evaluating, and we'll continue to do the investment and projects internally and see where things go next few years.
Okay, Isaac?
I think I was talking about the aluminum process before, and that's kind of obvious. The reducing scrap was a goal there. But to piggyback on the OEE, we have a project running out of Akron, Ohio, that we're looking to improve our overall equipment effectiveness, and that's a steel plant. And I was very, very focused on the ROI in that project because I wanted to prove ROI within a year. So we were very focused, doing a very small project with them, focusing on what the biggest problem in the plant was. And that plant is an old plant. It's got equipment in it that's 35, 40, 45 years old. So we actually didn't have, at that time, we didn't have any data coming from those machines. So we actually sensorized those machines. And nowadays, the ability to do that and pretty inexpensively is there. So we decided what sensors to put and what locations of that machine. And, you know, when in the steel process, the scrap rate is not that high. The biggest problem is that line breaks down and production stops when it's a bottleneck. But we also know that if we can improve the function of that machine, a lot of times machines breakdown lead to quality issues as well in the production. So we have the pilot running and it's in full swing. And we've calculated that we can start getting ROI after 9 months with the machines that we have it connected to.
So I have a follow-up question because I'm interested, because in your casting operations, don't you qualify a part before it moves downstream in the operations through this learning algorithms?
That's a project that we're working on in the middle of.
Okay.
We've only pulled the data off and proved that we can predict a bad wheel. The issue is being able to mark an aluminum wheel that goes through a heat treat process and some other processes that we can track that wheel, individual wheel, through the entire process. If we can start doing that, then we can start predicting exactly what casting machine and what parameters are running on that particular wheel when it was made. So,
Okay.
yeah.
All right, thank you. So, excuse me, Hip. It's not working. Oh, here we go. Okay, some of the, obviously, we have a lot of legacy equipment. We have equipment that might be newer, or they have a large engineering staff, but a lot of companies run through challenges and during these integration processes. So I would like to have each of the companies that had an integration problem, integration issues, talk about what challenges they face during integrating machine learning algorithms into their factory equipment. And if so, are there any connectivity standards that might be employed to ease the integration that would have simplified it? So I think, Paul, did you have a slide for this?
Yes, yeah, I have a slide. I'll put it.
Okay, thank you. So Paul, why don't you speak to this, please?
Yeah. Yes, here we go. So what we're showing here is the PAC-ML standard deployed on a line where there's multiple machinery, different control platforms. Of course, on top of that is the OPC UA. We have a companion spec with them. So that's showing how the information moves, the pack tags, command tags, status tags, and admin tags, all of that, moving together. But the point I want to make here, just the emphasis here is that in order to deliver integration, there's something that's required first. And I think I'm sitting in front of an audience, a bunch of technical folks here. So some of you have taken calculus, and you know in order to do integration, there's something you need to do first, or know first, and that is differentiation. So that is the key here. You need to know what the configuration of all these elements are and set them up in a way with standards, open standards. So when you bring together, the integration process just goes seamlessly. And I think that part is overlooked. People are just buying stuff, using all these different criterias, and not looking at them coming together easier. That's the message here, and that's an opportunity even in this gummy bear application that we did. We bought another system upstream, a different vendor, but there was some complexity. We did not link them. We didn't tie any of this to the cloud. This was all local stuff. It moved us to the next level, but we're falling way short of where we need to go in terms of true integration.
All right, thank you. Do you want to skip to Sankara, please?
Yeah, in our case, we don't have the same level of machine level integration with AI yet. The example that I shared on the inventory one, especially, that's I think there is the challenge there is the data integration, because we have different systems, and you need to have I think it's SAP HANA that has to integrate into the machine learning system we are using. So that was a big part of that development process that had to be worked out. We don't have a lot of plug and play yet. We have a big spectrum in terms of factories at different levels of maturity at John Deere across the world. One of our factories in Germany, in Mannheim, is probably the most advanced in those systems in terms of at least connected devices and connected machines. I don't think we're using machine learning to do anything there yet, but definitely there's a lot more maturity in some factories than the other, and others are in different levels of their journey. Standards would definitely help, but that's what we have, at least for now.
Okay, great. Isaac, do you have any input on this?
I think the biggest, there's a lot of challenges for sure. I think one of the biggest things for me was how quick can I do it to see the ROI, and how inexpensive can I do it. And we actually utilized our cloud infrastructure. And to be honest, once the biggest lead time was probably getting the equipment, the sensors, and the local industrial PC and things like that. And once we got those things in order and we set up a cloud infrastructure with the server on our internal cloud, it was relatively quick. So I think that was our biggest challenge, is figuring out how to do that quick and inexpensive.
Great. I'm sorry, Kevin, I didn't mean to overlook you, but do you observe any integration challenges from your base?
Yeah, we actually encounter them on our own floor. We have a test bed factory, and we build out test beds, discrete manufacturing line that's highly instrumented and applies some machine learning tools in order to drive predictive maintenance and improved quality. And the aggregation of all this disparate data, I think, similar to Paul's point, can be incredibly difficult for systems that weren't designed to be connected in the first place. So, we have the luxury of putting a lot of engineering time into translating these protocols, creating sometimes custom circuit boards in order to aggregate the data and make it universally available to the tool set above it. And then, we have to document this and make it available to our members as kind of a playbook for how they can overcome some of these issues. We're increasingly getting involved in ISO standards and other standards bodies to help inform the development of these interfaces based on the learnings that are coming out of our projects.
Okay, perfect. Thank you. So the next question is really, what benefits do you expect to achieve from these initiatives that you're undergoing? And higher quality finished product, reduced downtime. What are your real ultimate goals in this particular initiatives? So Paul, you want to speak to that a bit?
Yeah, I'll be quick on
Should I
this.
jump
See,
in?
time is of the essence.
Yes.
Here, I just want to highlight, we got all the traditional benefits, improved quality, and so forth. But there were some unplanned benefits just I'd like to highlight real quick. One was decision-making was improved on the line. Whenever there was a non-conforming product coming down the line, this machine would tell you what's going on. And there was almost, at times, be a 21-gun salute. In other words, those air jets you saw, there would be that sound in the plant. So problems became more transparent. So decisions were crisper. The resource that we required to remove the non-conforming product would actually be less, and there would be less occurrences. So those are some nice, takeaways that we got.
Yeah, that might be a better way to answer the question here, is thinking about those unanticipated benefits. Rather than, I mean, we all know what we're trying to achieve, but I think a lot of us understand. But was there anything unanticipated? I mean, if you want to answer it in that perspective, but, I don't know, Kevin or Sankaran, did you have any unanticipated benefits you achieved?
Mainly it goes down to delivery cost and quality. Like I mentioned, some of our machines, the factory where we're trying this is a big machine and thousands of parts. If any one of them doesn't, if there's a quality issue or supplier issue, we have a line down situation. So something that we cannot afford. So the biggest benefit is make sure we don't have overstock in inventory. At the same time, we don't have a line down situation. That's the primary driver for us.
Okay.
So quality benefits, yeah. I don't have numbers, but yeah.
Okay. And Isaac, did you have any unanticipated benefits that you achieved from these?
I don't think it's necessarily unanticipated. I think it was a little overwhelming when we started putting the machine learning algorithms against, especially the casting process, to learn. In the low pressure casting, scrap rates can be 15 to 20% at times. So when we went through that process and we did an analysis I have over 110 pages of an analysis that we've done. And in our last set of analysis, we were able to predict 80% of the scrap if it would have been a scrapped wheel. And if we compared that to the numbers that we could save if we just were able to save 1% scrap, just the power of 1% is what we would say is significant. So, and using machine learning, I think it was surprising to us how much we potentially could save above that 1%.
Well, it's good to hear.
Yeah.
Did you want to have an input?
Yeah, I was just going to say that, from an institute's perspective, we aren't at that point so much in what we do where we get the unexpected learnings. However, I think knowing that that's how AI projects often run is a good thing to be aware of. In other words, many people in manufacturing are familiar with making investments for the sake of a known result. But when you collect data and then unleash data scientists intersecting with domain experts in that area, you should be prepared for discovering opportunities that lead to more questions, the acquisition of more types of data that drive further opportunities. So you can start with a hypothesis, but learning can be messy, and machine learning that much more.
Mm-hmm. Oh, thank you for that input. That was good. Now, for those of you that have undergone deployments, if you were to undergo these deployments again, what would you do differently? So, Paul, since you
I'll be quick again. What would we do differently is to know what our learning curve is for machine learning. Like investment, you got to know what your investment style is. Well, we didn't know, and we didn't have a discussion about that. And that's the key learning for us. That's what I want to highlight.
Kevin, do you have any input, or do you want to?
Yeah, I think for what we do differently is ideally if you're going to install a new line up front, you should invest in some taxonomy or ontology work to make all of the data that you can possibly imagine wanting to get down the road universally available to your algorithms, to other organizations within your company. And so having a data architecture up front would greatly facilitate that access to information that you're going to need in order to do the discovery that I mentioned. So some of the most leading companies that are part of our membership are rightly investing in that kind of data lake architecture, very structured approach.
Okay.
Sankar?
By no means we are redeploying again, but again, like I said, we're in a journey, and to be honest, we don't have a lot of people who have good knowledge of machine learning. We have a lot of data people. We do a lot of data analysis with warranty data, reliability predictions, tons of dashboards, traditional data analysis, statistical methods. We do a lot of that. Machine learning is something we slowly need to build our capabilities on some of these things. One thing I want to answer here is don't think machine learning is only for the guys in IT. So I want to go back to the journey with Six Sigma because I have a long history in that space. So when I started my career, I was a young co-op at Ford. And first day I came in, my boss handed me a book of design of experiments. So I had to go to a statistician. We had one statistician in the building. I would go to him, help me set up these experiments. Then over time, when Six Sigma came along, thanks to Motorola, and we gave the power of statistics to the engineer. So we had tools like Minitab, Statistica, that basically you made the process or the functional knowledge owner to learn these tools. And that's where I think to Isaac's point, the process owner, the people who have the experience, science hasn't changed. Okay? Newton's laws still apply. So that hasn't changed. So you are enabling these processes and systems to be enabled with this machine learning. So I think one of the things we are learning and we need to do is bring the knowledge of the process and give some of these tools in the hands of the knowledge experts and bring the folks from the IT also together to make these things happen. So that's the critical piece, that all these things have to come together. It's not just an IT initiative. So the business side, the process side, subject matter owner, all come together. That's what we are learning, and that's the kind of things we are trying to do in all these areas, all these applications.
Perfect. Thank you. Isaac?
I have a hard time with this question, and I'll tell you why. It's because you don't know what you don't know. So I don't know if I knew what I know now. There's a lot of things I think that I would focus on more closely. And to the point that he just made, it's been a journey for me of really a culture shift in the company, to be honest. A lot of education, a lot of people needed to pick their heads up from doing production on the plant floor, and we need to be much more of a matrix organization. As you said, IT and OT convergence, I think you probably heard that this week, is very, very important, but also not just IT and OT, but through the entire corporation. It's very important that we start looking across and stop working in silos, and that goes with data too. We need to that data needs to be joined, but then also those teams need to be joined together, and we need to work together. So I would say that's what I would focus more on if I was to do this again.
So, but you had brought up a point with regard to your employees or the workforce recognizing failure modes in a machine from sight, smell, sound, feel, things of that nature. Now, when you employed a machine learning system, which would be kind of supporting them, was there any kind of issue with regard to trust that you would have trained them before you deployed, or did you train them before you deployed to trust the system? And did you run into any challenges there would say, gee, I would go in and educate the employees first, or?
There's definitely getting to know the plant and who's in the plant and who's on your side and who's not on your side is part of the process. And then getting those guys who are skeptical on your side is a huge obstacle. Especially I can think of in a particular instance in Akron when we were putting the machine learning system in, that the maintenance guy who'd been there for 30 years is kind of like, I don't need that. And also, there's also the perspective that we're putting this in to spy on you. So there's definitely some people who have that perspective, and getting them on your side and showing them that, like you said, this is to help you. This is not to cause you a problem or to spy on you. Yeah, it's definitely an obstacle for sure. Yeah.
So the same point, Paul, did you run into any kind of workforce-related issues? That
Yes, and I'll just show that slide here. Just move ahead to.
Move ahead?
Yeah, to 7. There's a graphic here. I just want you guys to fully appreciate that a typical maintenance mechanic, let's say 50 years old, very capable, could struggle with this technology. And I wanted to show you because
I'm struggling with this technology.
Oh, you're struggling? Sal meets the criteria, yo. Go past that. Go
I'm
past
sorry.
that. I believe it's the. There should be a picture of a HMI screen. Okay. Yeah. One more. There we go.
Okay.
All right. So here's what you got going on here, real quick. You see, there's a cloud of good product. The green, the belt itself, right? You see the red, that's a bad product cloud, and that orange area is what the threshold. This is where the neural network and the machine and deep learning stuff comes into play in terms of making a distinction between the good, several of the good, and the bad, and how much you're willing to accept in terms of your good being given away, all right, to capture all your bad. This whole activity, I see the actual HMI on the left, that typical mechanic may not be able to get this in this space. The gamers, the millennials, the Gen Xers, perfect. But we couldn't put that down in the job spec. HR slap us around, okay? So this what it took. We had to overcome some of these things, and that's what this is all about. This is a new thinking, new space, and to make those moves.
Perfect, thank you. So I think I jumped ahead a little bit on the previous question.
Yeah, I think that's good.
So that's fine.
To that last one.
So really, I wanted to address the issue of staffing, training, and how machine learning adopted in the production environment has affected this. So, I mean, we addressed some of the challenges already, but was there any reduction in staff as a result of machine learning and any workforce reassignments necessary in any of these applications? Isaac or anybody?
Not at this time that I know of.
Not this time?
There is no real change in personnel. So the second question, especially, we are, like I mentioned, you have technology, you have processes, and you have people. So we run our business on 4 core processes. I can mention that it's nothing new. It's pretty standard stuff in most manufacturing industries. One is the customer acquisition, which is, understanding what the customer wants. And then you have the product design, which is, you have a design process. We call it our product development process, PDP. And then you have OFP, which is the order fulfillment, which is basically manufacturing or production. And then you have customer support. So within each one of these processes, we have various functional areas from design, manufacturing, supply management, testing. All those are built processes along the way. So in our PDP process, we have like over 1,000 steps. So we are very process-oriented. So things have been going on for years, for decades, using those core processes. And then we switch to these tools to enable or make those processes more efficient. It's a journey in where it can be helpful in making us more efficient. We are also about speed to market. So we want to be more efficient in our delivery process, that we can get the customer needs to the market faster and faster. So if anything that can help us deliver those faster with the customer needs, that's what we are after. We are not looking at this in terms of reducing people or anything, at least at the headcount level at this time.
Great to say, we're manufacturing, and in general, we're very lean, Six Sigma. We have these things that we've already done, and I think if you walk on a manufacturing floor and you ask a plant floor guy, operations guy, a maintenance guy, where their time could be better spent, I think 100% of them would have a story about, I really would like to, or I should be spending my time on a particular function or area, but they don't have time because of machine downtime, because of product quality issues, so on and so forth. And Kevin alluded to it, like when you look at those machine learning and you sit in that room with those people and you go back and forth with them, you discover things that you didn't know before, and you can't discover those things without those production guys. And I've talked to people about this before, this fear that AI is going to replace jobs, and I don't think it will replace jobs necessarily. I think the skill set will need to change. People's skill set will be a little less technical and a little more soft skills and more of knowing the whole breadth of the business and how the business functions and how they can incorporate AI.
Okay, great. Go ahead.
Yeah, I have, part of the benefit of being an institute that where we could see what a lot of manufacturers are doing, there's a specialty glass company that's 70 years old that's kind of in our backyard on the south side of Chicago. And a new owner came in 20 years ago. The workforce was unionized and had a very adversarial relationship with management when he came in. He had a big customer, GE, who was buying their engineered glass for oven doors, consumer oven doors, and had to increase throughput 15%. Otherwise, he would lose the sole source contract to competition. And he couldn't afford a new building. He had to stay within his current footprint. And he incentivized the entire team, all shifts, to brainstorm and be about this continuous improvement and look for opportunities to apply digital technologies at first and ultimately some artificial intelligence. And by fusing together some people with data backgrounds, domain knowledge, and even people who just had self-learned skills in mechatronics and so on, they recommended and prioritized various improvements that would have the biggest bang for the buck, so to speak, and achieved the goal of 15% throughput, which triggered an extra paycheck a month for everybody in the company that he paid out in cash, grossed up for taxes. And I got to tour this plant, and I'd never seen a workforce so warmly greet the owner as he toured the factory. But he did this over many years, continued to increase the targets and create lucrative payouts for the staff. And it was a great way of creating a culture of continuous improvement that, Isaac was talking about. Sometimes the initial reaction is like, why do I need this technology? So rather than shoving the technology down the throat of your operations people, find ways through hackathons, a shared vision, some aligned incentives to engage them in helping define what the manifestation of that vision looks like. And that's one key step. The other thing is recognizing that people change, culture change is intrinsic to this work. We've worked with some members to create a jobs taxonomy, which is basically mapping the generations of roles in an organization as digital manufacturing takes root. And this has helped some companies, like for instance, Dow has their tier 1 member. They've publicly stated that this has helped them design their digital manufacturing organization. And it helps us to plan more proactively for the experiences that some of your existing staff needs in order to fulfill the roles of tomorrow, as well as recruit totally new roles that you hadn't had to in the past.
Okay, thank you very much. We're running a little bit out of time, and we have a few other questions, but I'd like to just make this probably the last question. And this has to do with the perspective of how the cloud will play in the machine learning environment. So I'd like each of the speakers here to talk about their perspective, the role the cloud could or should play in these solutions. And what's the comfort level in the organization regarding the use of the cloud, for, putting large data into out in the cloud, and whether you have on-premise solutions or data sharing with partners. Have you evaluated any of these types of solutions so far?
Okay, I have the slide up there that I'd like you to advance to speak to this. Just keep going. I believe it's towards the end. Okay, while he's getting there, we have.
That's it?
Yes, that's it. We have within Church and Dwight, Microsoft Azure, with OPC, UA, backplane and all of that. We started on that journey about 2.5 years ago, and we think there's going to be more and more of that we have to be more strategic. Now, what I'm showing here is a visual. On the left, that's the Tower of Babel or Tower of Babel. And why is that relevant? Here's why. And you see OPC and what's going on here. I'm not saying they're analogous, but I want to make a point, okay? And I think it's important as end users that solution providers hear from us, all right? And that, we make the adjustment if we're not on the right track. And that is This is real. This ziggurat, this building, this is historical, where early man came together. They only spoke one language. They took their brick as stone, their tar as mortar, and they built, working together, true collaboration, what they call the gateway up to the sky, all right? And that was literally the meaning of Babel then. But by the end of that project, the name changed. Not the name changed, the meaning changed. Babel now meant confusion, Babylon, because they were rebellious, what they were doing. But what we see is the good now, that they collaborated, they worked together. And that's what it's going to take to fully maximize everything when it comes to the cloud and everything when it comes to getting our data to the cloud, which is what OPC UA and as well as PAC-ML helps with the machine-to-machine piece. So this is vital that we view it that way, and the solution providers should not view this as building their own tower of technology. This is bigger than a single vendor. And I heard you said that earlier, didn't you? It's bigger than a single vendor. This is like the first wave of revolution that we had when we had steam energy. That was for everyone, bigger than one. Then we moved on to assembly line, bigger than one. And of course, the PLCs, PCs, and the internet, bigger than one. We're at the same space now, where it takes everyone coming together using open standards to fully generate what is out there for everyone. This is disrupting business plans, and we need the solution providers to step up. You know, we have a president, one of our presidents, Eisenhower, he said this. He says, neither a wise man nor a brave man will lay down on the tracks of history waiting for the train of the future to run him over. So why is that relevant? That's relevant because there's some solution providers that think they're on the right track, that they're doing stuff, they're in part of discussions. But you know what? They're not on the right train. The train of the future is right now, and that train is called open standards. And some people are trying to do their own field bus, trying to deliver this solution, trying to have prime mover advantage, and that is not the way to deliver this. We've got to step up, we've got to work together, and we've got to make this thing happen through open standards, through collaboration, and that is my message.
All right, thank you. All right, Kevin, do you have a perspective on the,
Yeah, the cloud is essential for certain applications for sure. I think as we get more comfortable with it, more and more will depend on it. But we have, for instance, projects that require the cloud because we're seeking to integrate sources of data from across the supply network in order to, for instance, do dynamic scheduling of production operations based on the availability of incoming material, getting better prediction as to when that material will be received. For instance, that was a GE project with University of Washington. Blockchain applications that allow us to verify the provenance of an assembly and all of the components are going into it to certify, you know, anything from ecological, environmental, or ethical compliance. Requires ultimately the cloud and some sort of security like blockchain in order to keep that with integrity, that information. But there are many other benefits because the vast majority of the supply network are very small shops that don't have an IT person even on staff. And the only way we're going to be able to afford them the tools and the security that they need is, I believe, through trusted cloud solutions that can help, you know, bring them forward without having to make those investments themselves.
good point.
Regarding the cloud, can you hear me? Okay. Definitely, we are both internal and external. So we are one of the probably major users of AWS for a lot of the machine data. So all the machines on the field, all the data goes to the cloud, AWS. But we also have Microsoft Azure for a lot of the internal business stuff. To be honest, funny. It's in the last 5 years just like 180-degree turn. 5 years ago, our IT guys would never let us put anything on the cloud. Now they don't want me to keep anything on my laptop. They want everything on the cloud. So it's a big transformation and a culture change for us to go there and in feeling comfortable with the security and stuff. So that's definitely so. We have a lot of stuff on the cloud, but some cases you saw the example of Blue River stuff like that does online. You need still edge ML. So we need combination of both. It depends on what it's for. So data latency and how quick you want to make decisions. If it's going to be live, it's going to be continuous feedback, then we can't wait for the cloud or have it to go to the cloud and come back. So it's too slow for that.
Okay.
So we need a combination of both.
Thank you. Okay. And
Yeah, just
Isaac?
real brief. My perspective as an IT guy and in the company that we are is a place like Microsoft Azure, AWS. Their business is the security of our data. So the amount of equipment they have to make sure that our data is secure is nothing we could ever afford to put in. So from an IT perspective, I have no problem with putting that data in the cloud. And the one thing that I can tell you that is a kind of a challenge is the amount of data, especially if you start hooking sensors up to machines, and particularly vibration sensors. It sends a lot of data, and you don't want to send all that data. So if you, we've definitely taken the posture, the stance that, yeah, we need to do the computation in the cloud, but we're not going to send all that data up to the cloud and have edge computing or fog computing, whatever you want to use, and have an industrial PC that's doing some analysis of what data is important, what data is not, and then deciding what data to send to the cloud is where we're at and what we're doing. And we're doing an analysis, not only that, of the bandwidth, because we're going to have to start thinking about extending some of the bandwidth of some locations because of the data that we want to start sending to the cloud.
All right. Well, thank you very much. Well, I think we have a lot more questions here, a lot more discussion points, but for the sake of time, we're going to conclude at this point. But I hope what you all came to realize it is some of these things we've been talking about through the digital transformation, the use of AI or machine learning techniques aren't in the future. They're really the present. And so we're seeing deployments, we're seeing real results, and future improvements and actions that are going to be undertaken as a result of these. So I hope you all enjoyed the session as much as I did, and enjoyed having these gentlemen here and taking the time out. It was absolutely wonderful. Thank you very much, gentlemen, for all of your effort. Thank you.